For today's webinar, we are going to talk about watertight shoring systems and its application for engineering industry. Yeah, so for our presentation today, this is the table of contents. First, we have introduction for shoring systems. What are shoring systems? What are the temporary earth retaining structures? And then second point, we have the complete overview for our presentation. What's our plan today? And then we have the basic fundamentals. We have the theories, design, structural design, and geotechnical design. And also we have the construction methodology as well. And fourth, we have the case study. We brought today one project which is constructed already before, and we can show how we implemented the theories and the application of the shoring design in this project. And five, we have the state of art, and we have some advices for the revolution or evolution in the field, how we can implement new technology and bring the quality up for our designs. And at the end, we have the career path, we have job opportunities, and we have some advices for the new colleagues or fresh graduated engineers. So moving on. Yeah, so what are the temporary earth retaining structures? Now, in order, if we have project like we have 6 basements construction or 5 basement constructions, or we have underground excavation for infrastructures, we need to install some shoring walls in order to excavate this project or our development. So simply this is the shoring system or the watertight earth retaining structures. And we can use it for residential buildings or normal buildings. Also, it can be used for infrastructure projects like metro lines or any underground surfaces. Also, we can use in marine application like quay walls or jetties or any marine application. So moving on. Yeah, what is the water tightness criteria? Yeah, just imagine if we have excavation and we have like this figure, we have a high water table here. In order to excavate, we need to do like the watering system here, and we need to install some water tightness shoring system. This water tightness shoring system can carry the water pressure, and the seepage will be allowed only below the toil level of these walls. So it's totally different than the non-watertight system. Non-watertight system, the water can flow through the system itself or through the shoring wall itself. Okay, so this is our overview. We have the classification for watertight shoring systems. Then we can jump to construction methodology for each type. And after this, we can talk about the geotechnical design and structural design. And finally, the case study. And we can give like some applications and advices at the end. Yeah, so we can classify the shoring system based on many points. First point, we can, with respect to the construction method, we have secant piles, we have diaphragm walls, sheet piles, steel sheet piles, and we have combi wall, and we have soil stabilization walls or cutter soil mix. Some people are calling it cutter soil mix. So first, yeah, and also we can classify the shoring walls based on its lateral support system. So for example, we have the cantilever walls, we have the anchored walls or propped walls. Moving on. Now we can discuss about the construction methodology for each type. First, we can start with diaphragm wall. For diaphragm walls, the first step of construction, we can do the guide walls or guide beams. This is just to keep the alignment of the wall as per the required design. Some excavation will do locally here 1.2 meter or 1.5 as per the type of the wall we are going to install. And 2 L beams will be installed. Sometimes it will be precast as well. And the shoring wall will be installed in between these 2 L beams. So first step is the guide wall. Second is the drilling of primary panels. If for diaphragm walls, we have primary panels and we have secondary panels. And the 2 panels will be intersected together in order to retain the wall at the retained side and prevent the seepage of the water. So the first step to install the big panel or the primary panel. Installation of primary panels will be first by drilling the panel, removing the soil from this panel, and then installing the steel cage like this photo, and then casting the concrete by trim pipes. After this, we can install the secondary panels with the same method, but here we have intersection between the green panels, which are the primary panels, and the orange panels, which is the secondary panels. This intersection, usually it will be 150 millimeter to 100 millimeter. And then we can proceed in our excavation, and if we have tieback anchors or strutting system, we can install during the excavation process itself. These are the two types of machines which we are using for diaphragm molds. We have the hydromill method or the cutter, and we have the grab method. But recently, most of the companies and people are using the hydromill because it's easy and saving time, and the quality of the wall will be more. Yeah. So second type of walls is secant piles walls. For secant piles, first step will be also the construction of guide wall, and secondly, we can install the casing, steel casing, temporary steel casing. And third step is augering and drilling of the pile. And secondly, we can install the steel cage and casting the concrete also using the trim pipe. With the same sequence which we used in diaphragm molds, here also we have primary piles and secondary piles. So first the primary piles will be installed, and in between the primary piles, the secondary piles will be installed with some intersection with same application like the diaphragm mold. And the process will be repeated till we finish our work. And in this figure, we can see the sequence of work. Here, if we can see the secondary piles, and here's the two primary piles. And there's the process installing the casing first, and then drilling and casting the concrete with steel. For secant piles, we have the drilling rigs, we have bucket or boring method, and we have the CFA method or continuous flight auger. So based on the project and specification of the project, and based also on soil type and geotechnical parameters, we can choose any system and use it. But these are the two types of machines which are commonly used in this type of shoring walls. Yeah, third type of shoring walls, we have steel sheet piles. Steel sheet piles is commonly used in infrastructure works if we have some local excavation, and also it's used in marine application, in some marine application. So installing of steel sheet piles is different than the secant piles and diaphragm molds. The steel sheet piles will be installed using vibro hammer by vibration motion into the ground. And if we have like rock layers or something very stiff, some layers are very stiff, we can do pre-drilling first and then vibrate it down using the vibro hammer. You can see from this figure the sequence of construction also. The sections of the steel piles will be connected together in order to prevent the water to seep inside the excavation site. We can see, yeah. So here's the steps of construction of sheet piles. We have the ground leveling and the guide beams, and installation of the first sheet pile element, and then the second sheet pile, and the two sheet piles will be connected together. And here the same sequence will be applicable for all the stations after this. Yeah, in some projects we have the sheet pile, steel sheet pile. It's coming with fixed length, 12 meters approximately, based on the supplier factory. And for some cases, we need longer sheet piles. So in case if we have case like this, we can install the first part of sheet pile and then weld the second part of sheet pile and continue the vibration motion down in order to install the complete wall. So this, in some cases, you can face this scenario. Moving on. Yeah, the fourth type, the combi wall. Combi wall is commonly used or only used in marine application. It's a combination between steel circular piles and sheet piles. The installation sequence here will be the same like sheet piles, but it will be using like pontoons and some marine equipments will be required for installation. Here we have the last type of walls, which is soil stabilization walls or cutter soil mix. In this type of walls, the soil itself, the existing soil itself, will be mixed with grout mix or cement mix. It's something like the diaphragm wall, but instead of excavating the full panel, the grout will be mixed with the existing soil. So this can save more money and it will be more economical. Also, some I-beams can be installed as per the required design. It will be spaced I-beams. Also, we have between the panels intersection around 200 millimeters. And in market, this type of walls will be used for circular shafts and for micro tunneling projects. Because here in this type, we don't have steel and the tunneling machine can go here from the entry of the soft eye or the entry of the micro tunneling machine will be easy in this type of walls instead of breaking in concrete wall or diaphragm wall. So moving on to the design, we have two steps of design. We have first the geotechnical design and structural design. So talking about the stresses, here we have what is the difference between the water stress and soil stress, and what is the difference between the vertical stress and horizontal stress. Imagine if we have water and we have element of water here and we need to calculate the stresses, horizontal and vertical. So if this is the case, the horizontal, the vertical stress will equals D into gamma water, and the horizontal stress will be same. So if we have wall, the water pressure will be something like this, and the horizontal pressures equals the vertical pressures. But in soil, it's different. In soil, we have something called lateral earth pressure coefficient. The lateral earth pressure for soil, it will be less than the vertical earth pressure of soil. And we can go in details in the next slides. Yeah, so as we discussed, so the ratio between the horizontal stress and vertical stress called lateral earth pressure coefficient. And we have three cases we'll discuss in details. Yeah. So next slide. Yeah. So we have the first case. First case will be at rest. So for at rest assumptions, we are assuming that this wall will not move, and it's not designed to move actually. And the earth pressure coefficient will be equals 1 minus sin phi. And this, yeah, and if we have water pressures, we can calculate it, and we can discuss later for water pressure. So second case is active earth pressure. So in active earth pressure, we are assuming that the wall will move. We have lateral strain. So it's this case called active state. And the lateral earth pressure coefficients will be less than the at rest stage. So the stresses will be less than the at rest. And case number 3, which is the passive earth pressure. Imagine you are pushing the wall to inside or to the soil itself. So we have something called K passive, which is the reaction of the soil on the wall. So now we know the difference between the K naught. K naught is the at rest stage and the lateral earth pressure coefficient for at rest, and K active. K active is the lateral earth pressure coefficient for the active state, and we have passive. Passive is the lateral earth pressure coefficient for passive state. So we have three cases, we have three states. Here in this graph, we can see the difference. Here, at rest stage or at rest case, we don't have lateral movement, and the case will be K naught. Here we have lateral strain or lateral movement, and the case will be Ka or K active state. And here we have inside or to soil movement, and the case will be K passive. Yeah, and here is a summary for what we discussed now. Here we have if it's zero movement, we have K at rest stage, and if it's active, we have the active earth pressure, and if it's passive, we have passive earth pressure.